Hello, welcome to today's lecture. Before we continue taking double integrals over general regions, let's get back to what we learned before. Double integrals over rectangular region. It's just a quick review for you. Earlier, we learned that the development of double integrals is very similar to actually development of definite integral to find the area below the curve. To constructing a definite integral to find the area below a curve. We use Riemann's sum and we generate the exact same idea. Anyway, let's take a look at this short video. Well, suppose you have a surface lying above region R in xy plane, and below the surface it's given by function z equals to f of x and y. Well, what are we going to do? We're going to superimpose a rectangular grid over the region R, and as you can see here you have these little rectangles with area delta AI. Now we can just take random points in each of these rectangular shapes, these small rectangles, and then construct the prism. So each prism has base on this rectangle, and the height is f of xi, yi. Well, the volume is equal to base times the height. So as you can see, it's very similar to a chimney. Now what we're going to do, we're going to construct all of these prisms and add the volumes together using Riemann's sum. Very similar to what we learned in elementary calculus. Very well, as you can see, you have an approximation of the volume under the surface. And as you take the limit, these little rectangles are getting smaller and smaller. You get a better approximation for the volume below the surface. Very well. So if you have a positive function for a positive function like z equals to f of x and y, we can define the volume, which is defined as the double integral of function f of x and y dA over region R. So we also learned about Fubini's theorem, which says if function f is a continuous function, z equals to f of x and y is a continuous function over what? Over region R equals to all x and y's such that x is in between a and b and y is in between c and d, then The double integral over region R can be written as iterated integral. You can take the integral of a function f with respect to x, with respect to y. It means that we take the integral of the function. The inner integral is with respect to variable x. X ranges between a to b. So this is your inner integral. Then you take the integral of the quantity that you have with respect to y, and y ranges between c to d. Or you can say that, hey, I want to take the integral with respect to y first. So your inner integral is now f of x and y with respect to y, dy. Y ranges between c and d, and dx. So you find the quantity that you have, and then you take the integral with respect to x. X ranges between a to b. Let's take a look at this illustration here. Very well. On this side, we are taking the inner integral with respect to x. On this side, we are taking the inner integral with respect to y.